All right. Hello, everyone. Welcome to ScienceHolic's October webinar. So today, we're very pleased to have Juanita here with us today. She is a research assistant professor at Boston University in mathematics. So she'll be sharing her experience and advice with all of you today. So yeah, without further ado, Juanita, would you mind introducing yourself for a
Yeah.
moment?
Hey, everybody. I'm very excited to be here. Thank you for the invitation. So my name is Juanita Duque Rosero. I'm a research assistant professor at Boston University, and I do mathematics. So I did a PhD in math. I'm originally from Colombia, and I don't know what else do you want me to say, but yeah, that's it.
That's wonderful. Yeah,
Yeah.
that's great. Thank you. Yeah, and first of all, for those that are watching the recording of this webinar, thank you all for tuning in. We greatly appreciate having you all here with us at ScienceHolic. You're helping us make STEM resources more accessible for students of all ages and just spreading this exciting content for more people to see. So thank you. And yeah, so we're gonna get started with our questions. So first off, Juanita, how did you discover your passion for mathematics?
Oh, wow. So I think during school, I always liked math. And then I spent a lot of time trying to find something else to do. I was like, okay, I like math, and let me try to find something like a career in which I can apply math and apply the things I like about it. And then I kept trying to do that until I was about to graduate, and I had to choose what to do for college. And then it was just like everything else that wasn't just pure math. It didn't seem so interesting to me. It felt like the right thing to do was just to go study mathematics. So yeah, so I decided to do that, and it was it was kind of a weird choice in high school. I didn't see that many people doing it at the time, so it was it was kind of uh, a phase kind of thing. I don't know, and it worked out. So yeah.
Yeah, wonderful. Thank you. Yeah, next up, what did you study in school that sort of, maybe in high school, were there any like specific projects or classes that, really made you realize like, oh, this is something that I'm interested in?
Yeah, so I mean, I feel like the basic calculus classes were fun. It was fun to be able to look at a problem and then understand how the solutions worked. And I felt like I felt like I really enjoyed that kind of classes. But also, I think the parts that I enjoyed the most were like in the math classes in which I had no idea how to do something, or I made a mistake. Like I still remember some mistakes I made in my high school exams, in my math high school exams. And I think those were the ones that made me learn the most. And then understand that there was so much beyond the calculus that you learn in high school, um, that I wanted to learn more about. Yeah.
Wonderful. Thank you so much. And yeah, so you first got your bachelor's degree in Colombia. So what sort of inspired you to pursue academia here in the States?
Oh, I think the United States has a really good network of universities and research happening. It's a
Mhm.
really good place to be if you want to be a researcher. Um, I think one of the really amazing things about doing grad school in the US is that they will pay you a salary
Mm,
if you are a student. In most mathematics departments, it's given that they are going to pay you a salary in exchange for some work, but it's kind of something that everyone can afford if that's something that you want to do, and that was very important to me. And then yeah, it's I feel like universities work very differently here, and there are more opportunities to pursue research in mathematics. So it was something that I always wanted to do. And Yeah.
For sure. Thank you so much. All right, so next question. What was it like transitioning from your academic career to professional career? Were there any like big jumps that you had to make going into doing real research?
Yeah, I think I part of what I love about my job is that it feels like I've just been in school for uh, like more than 10 years, a very long amount of time, and I keep being at the school. So it's the academic career, just something where you can keep learning about things. And then you're interacting with students and you're at the university. I mean, you're not taking classes, but you're teaching the classes too. And it feels like it's almost the same as what has been happening, but there are, I mean, there are different responsibilities, and I think the big jump is just to get used to like to being productive by yourself, like um, kind of having the motivation to do the research when it's just you against your research, doing it for as long as you want to do it. So it's finding kind of that motivation to keep trying, even if you're failing at doing something at one moment, you just want to keep pushing. And I think that's a big difference. Yeah.
Mhm. For sure. Thank you. All right, so moving on with the questions. Could you tell us a little bit about the research that you have done? Is there anything in particular that, you're really interested in or that you concentrated a lot of your work in?
Yeah. So my first day of undergrad, I heard about this theorem that is called Fermat's last theorem. Um, that it's it's something, a problem in mathematics that was open for more than 100 years. So if you have seen polynomials, it is really easy to read. It's you're just looking for solutions for the polynomial x to the n plus y to the n equals z to the n. So when you have n equals 2, for example, you have x squared plus y squared equals z squared. And that should remind you of Pythagorean triples. So that should remind you of right triangles and the geometry that you know about right triangles. So the sum of the squares of the sides is the same as the square of the hypotenuse of your triangle. So for 2, there are many, many solutions for that equation. I think 2, 3, 5 should work as one of the solutions. But there are actually infinitely many. But when n is 3, for example, x cubed plus y cubed equals z cubed, you cannot find any whole number solutions that are not the silly ones like 101 or things like that. And Fermat's last theorem says that those are the only solutions that you can find, even when you increase n. There is nothing else there. So it's something that everyone can understand. It's a theorem, yeah, it's a theorem that has a very easy statement. But and the story about Fermat, why it's called Fermat's last theorem, is that Fermat was a mathematician who liked reading math books. He was a lawyer, and he liked doing math as a hobby. So he used to write in the margins of his books, kind of the things that he was noting from the theorem, from the theory he was reading. And then in one margin, he wrote that this is not possible, that there is no solution for the equation x to the n plus y to the n equals z to the n when x, y, and z are non-zero, basically. And he said, I have a marvelous proof of this fact, but the margin is too small to contain it. And it's been the proof that has been lost for 100 years. And nobody was able to prove it until the 90s, in which Andrew Wiles, with the help of Richard Taylor, kind of finished the last step of the proof of Fermat's last theorem. So it's just like, not only that this problem was open for that long, but so much theory was needed in order to solve it. And so many mathematicians work together to get to the final solutions. And now we know for sure that there are no solutions for that equation. So that inspired me a lot when I was an undergrad. And at the end, I decided to work on problems that are similar to this one. So I use computers to prove that polynomials like these have no solutions or have certain amount of solutions, and try to compute them all. Yeah, and the area of research that I do, it's called computational number theory. That's what I do.
Yeah, got it. Thank you so much. Thank you for sharing. That's super interesting. All right then. So next up, can you explain to us how you met some of the mentors that you've had in your career so far?
Yeah. So I guess the good part of academia is that you have mentors that are assigned to you, and it's kind of given that you're going to have a relationship like that. But I have also been able to find mentors not there, just by going to conferences and to events and talking to people and trying to find people to connect with in some sense. I found really helpful mentors just by asking for advice and asking for help, or just trying to find connections with different people in different settings. So I think if someone is looking for a mentor, the best thing to do is to ask someone else and to try to find something that you have in common with that person, and why would you want that person, and explain to that person why they are a good person to mentor you.
For sure. Thank you. Next up, what have been your most exciting career opportunities so far?
Oh, that's a good one. I feel like um, doing a PhD was definitely my uh, the best career thing that happened to me. I mean, like being accepted to a PhD program and then having a fellowship in which I could just do it without having to be in debt for all my life or something like that. It was really game changing for my whole life, I think. I don't know where I would be without it right now. And yeah, I'm trying to think of anything else, but I feel like I would pick that one.
Wonderful. Thank you. And yeah, so, with where you are right now with your career, what does your day-to-day sort of look like?
Oh, so I teach one class here. So I teach Tuesdays and Thursdays. Um, and the class is only 75 minutes, but then I have to prepare for class, answer emails from students, prepare homework, go to hold office hours. So that takes kind of half of my time, that of my working time, yeah. And the rest of the time I spend doing research. So research in mathematics looks very different than research in other areas. We don't have a lab. We just have a pencil and paper, basically, and we just make do with that. So the resources that you spend are very different, and you also can do research from wherever you want, basically. So my research looks like meeting with some collaborators on many days a week to try to talk about what we're doing and try to figure out what it is that we're trying to prove. And so it's a lot of collaborative work. And the cool part is that I have collaborators all around the world, but we can still work in the same math together, and it works out perfectly. So I think that's a big difference between research in mathematics versus research in other areas, in which you have to be at the lab and you have to work with people at the lab mainly. Yeah, I think that's it.
Hmm. Yeah. Are the majority of your collaborators people from abroad?
Mm, mm, I think it's 50-50. It's
Okay.
yeah, in math it's we have a common language with everybody else and we speak in
Yeah.
English. So it's very easy to find yourself working with people from other countries and also visiting them to work.
Hmm.
Yeah.
Yeah. Lovely. Thank you. Um, and yeah, next question. What's one piece of advice that you would share to, your younger self, or you can think of, a current high school student who's thinking of pursuing mathematics? What advice would you give to them?
I think to get used to thinking hard about things and not being afraid of failing at thinking about those hard things. I feel like I see it in my students a lot now. I feel like we are getting more and more used to just having the answer. Like if I don't know something, I will just Google it and then I will know it in 5 seconds. But to be a mathematician, you really need to get used to thinking about a problem for days and months and weeks and years sometimes. So having that setup in your brain that allows you to do that without getting frustrated and with is is very important. And I feel like it's something that I learned very late in my career, in my education. So I feel like I would be a way better mathematician if I had figured that out earlier.
Hmm. Yeah, great. Um, And yeah, this will be our final question. But this also ties into our previous question of are there any specific activities that you would recommend for high school students to do?
Yeah, so lots of universities have programs during the summer aimed at high school students um, that want to learn more math and the kind of math that you don't learn during during your math classes in high school. So, for example, Boston University, where I work, has a very big program that is called Promise, where high school students come here. I forget how long that the program takes, but it's during the summer, so people can apply and yeah, they can participate in one of these programs. I feel like if you are interested in math, that's a really good option because lots of these programs are taught by grad students around the country, and it's yeah, they give you a different perspective on what you can do with math and how is it like to actually do the math that we mathematicians do. I think that's the biggest advice. And the other advice is just to have fun with it. I mean, there are more and more there are math puzzles that you can find online or math olympiads problems that you can also find online, and maybe you can have a club in your school in which you solve these kind of problems. You can participate in these competitions or just do it for fun, and they just there is so much to learn out there. And if you feel like you enjoy mathematics, just yeah, keep learning all of these things and follow your passion.
Mhm. For sure. Thank you. That's a wonderful note to leave us off at. So yeah, that is going to wrap up today's episode of our webinars. You all can continue to find more content from us by following our Instagram at ScienceHolic Official, or you can visit our website, scienceholic.org, where you will find our seasonal magazines as well as recordings of past webinars. So once again, a huge thank you to Juanita for her time here today. And yeah, thank you all for watching.